Very simply, simultaneous multithreading is the ability for a single processor to issue instructions for more than one thread context at the same time. With a single-threaded processor, you're effectively running serially, where the threads of execution can be switched between using an operating system or a scheduler, but they're actually running in serial fashion. So the operating system can manage the execution of parallel software threads based on priority or other scheduling considerations, and over time they will appear to run in parallel. But if you look at a cycle-by-cycle level, they're still serialized in the system, and there is overhead required to switch the context, and overhead meaning additional cycles that are not doing useful work. So what multithreading allows is for the ability to maintain the actual thread context in the hardware, and that can remove the overhead of switching between the thread contexts when they're running in the CPU itself. And that lets, even if it's a single issue CPU, it may be serialized through the execute portion of the machine, but you're saving on the overhead side, and so you're not wasting time without actual compute happening in the CPU. When you move to a superscalar architecture, where the CPU can issue multiple instructions per cycle, even for a single thread, then you can move to simultaneous multithreading, where you take advantage of this and allow issuing multiple instructions from different threads in the same cycle. That brings more complete parallelism, where the CPU can issue multiple instructions from multiple threads performing work at the same time and keeping the machine full, doing useful work during the processing and execution.